Okay. Good morning. Good morning. Good morning. Okay, let us start the course. So before I go to lecture 1, let us talk a little bit about the course, how the course looks like. I mean, this course is, in terms of loading, is a combination of 2 undergraduate course, 2 undergraduate statistics course would be given in 1 postgraduate. So what does it mean is that sometimes, when I talk, when I explain, I could be a little bit fast, but don't worry about that because we have so much materials. We have materials on the tutorial, we have additional questions. So don't worry about even if I have sometimes could be a little bit fast, but you don't miss anything because of that. Because the course is a bit heavy loaded, given that it is a combination of 2 undergraduate statistics course. So welcome to the course. This is a kind of welcome. I don't know what's happening with this side, but anyway. Okay, so this is my name. So Tamasgan is my name, and this is the email address that you could use. And this email address could be accessed by me as well as usually by the course administrator. So the course administrator will send me an email if it is about the course, but if it is about tutorial, about any other issue related to the course, then he will reply. So Anthony would reply to you if you want to change your tutorial. I will upload this one, don't worry, I will upload this information. Anything to change your tutorial sessions, anything to do with your deferred exam would be replied by Anthony. So Friday 10 to 12 is our lecture. I will upload the lecture note on Tuesday so that you have time Tuesday, half day of Tuesday, Wednesday, Thursday. We have 13 teaching weeks, but we have 11 lectures. The reason for that is that we have 11 lectures. We don't have lecture in teaching week 4. In teaching week 4, we don't have lecture because in teaching week 5, the whole tutorial will be simply a mid-semester preparation tutorial. So in teaching week 5, you don't have tutorial. There is tutorial, but the tutorial is not to cover new material, rather, to make you prepare for your mid-semester exam. So because of that, because there is no tutorial, when I say no tutorial, no new material will be covered during teaching week 5, but the tutors would try to show you or to prepare you for your mid-semester exam. So we are losing 1 lecture here, and the last lecture would be a revision lecture. So we will go to past exam, and we will do the past exam together. The recording would be available once probably today, sometime after 12 p.m. you will get the lecture recording. Tutorial consultation will start week 2. Tutorial questions will be uploaded on Wednesday, which means yesterday, before yesterday it is uploaded, and the solutions would be every Friday once every tutorial is finished. And these are the tutors that I have. The only reason why I put a different color here, these 3 is different color because these are the new ones, but these have been with me for a number of years. So I have been teaching this course for the last 6-7 years. So Ruben, he has been with me for almost 6 years, the same thing 5 years. So many of them, they have been doing as tutors with me. These are new, but even if they are new, they have already got 7 in the course. So the assessment, we have online quizzes, 10%, mid-semester 20%. We have statistical projects, so 2 parts. The first part, 10%. You don't need to take pictures. I will upload it on Blackboard. No need. I will upload on Blackboard. So project 1, 10%, project 2, 20%, then the final exam will be 40%. When we come to the online quizzes, these are in teaching week 4, 6, 9, 11, and 13, you have quizzes. So teaching week 4, for instance, quiz covering lecture 1, lecture 2. In teaching week 6, a quiz covering 3 and 4, and so on and so forth. 5 multiple choice questions. There is no calculation. It is just conceptual type of questions. You have 15 minutes to do, and you have 2 attempts. So it will be opened between Wednesday and Friday. So 48 hours, Wednesday to Friday, but you have only 15 minutes to do. Any time between this time, you have 15 minutes. You have 2 attempts. So it is a countdown. Once you start, the time is counting. You cannot stop and start it again. So it is a countdown, but you have 2 attempts. So please, for instance, if you get in your first attempt 5 out of 5, please still try the second attempt. Why I'm saying that? By doing the second attempt, you will get new questions. And you will test yourself, your knowledge, using those another 5 questions or another new 4 questions. And that would help you for your preparation, mid-semester exam, final exam. But we will take the best of the 2 attempts. First attempt, 0. Second attempt, 5. We take 5. So we take the best one. But I encourage you to try again, even if you get 5 out of 5. So these are the datas to quiz 1, quiz 2, quiz 3, quiz 4, quiz 5. We take 4 best. So we take 4 best out of 5. So this is all about quiz, which is 10%. Then you have a practice quiz. Some of you might not have if you have already done online quiz, it doesn't really matter, you don't need. But for those who are new, you could practice, we have a practice online quiz. It has nothing to do with the course, but there are simple questions that I prepared this one so that you would practice, how to do, how to submit, and things like that. So if you would like to do that, this would be open throughout the year, throughout the semester. So you could try before you do your quizzes. Otherwise, sometimes you might press something different and your quiz might not be really gone to the system. So please practice first. Mid-semester exam, now we don't know. We don't know whether it is August 31st. So it is a Saturday exam because it is a big class. It is a Saturday exam. It could be August 31st, 7th of September. It could be 14th of September. It doesn't matter which date. We will cover lecture 1 to 4. Lecture 1 to 4 would be in the mid-semester. If you are doing 14th of September, then probably you have plenty of time because during this time, probably we are in lecture 7. So it is a 90 minutes with 10 minutes reading time. The format, multiple choice questions, true false questions, and workout questions. So calculation questions, multiple choice questions, some multiple choice questions, you might need a little bit calculation, but I will prepare for the multiple choice questions. I will prepare a practice multiple choice questions before the exam. So you will have a practice MCQ before you sit your mid-semester exam. The same thing for the final exam. In final exam, also there is MCQ, multiple choice questions. I will prepare for you also a practice MCQ. That practice MCQ is similar to the real exam, so it would help you. We have a project 1. You could do it in a group of 2, or if you want to do it individually, you could do it also individually. Group of 2, any group of, not in your tutorial sessions, but any person here. So you could start forming a group if you want to do that. So it could be done, a group of 2 or alone. The submission date, 27th of September. I would put the questions on September 13, so you have 2 weeks' time. In 2 weeks' time, you submit. So if you feel that 2 weeks' time might not be enough, it is better to do it in a group. But sometimes, sometimes because we always ask, I don't know this time, I have to ask with the course administrator. But usually what we do in the previous years, if there are 2 students forming a group, it is only 1 student that submits, not the other person. 1 person would submit. But the person who didn't submit, it is his or her responsibility to ask his partner whether the assignment is submitted or not. There was a case where a student informed his partner that he submitted, but in reality he didn't submit. So it is your responsibility. This semester I don't know. Probably we would change it and both of you could submit the same material. But if in case it is only 1 person is submitting, you form a group, you have to ask the person, please give me, the number. When you submit, you will get a kind of receipt number. So ask your partner to copy and send you that confirmation. Otherwise, it would be difficult for us. Definitely for the person who didn't submit, we will give 0. But for the person who thought that it was already submitted, it is really unfair to give 0. Because the person thought that it is already submitted. But anyway, we will talk about that. So you could be late only 3 days. I mean, if you are sick and you have medical certificate, that's fine. But if you are 3 days, there is a penalty, 10% each. So 1 mark for 1 day, another one for the second day, another one for the third day. After 3 days, there is no mark. So if you have medical certificate, that's fine. And again, you have to follow the instructions. Sometimes I would say that, please use this data set 1, if your family name starts from A to F. So it is only for those students. If you are doing another one, you are doing a different data. So please read carefully. If in case you don't know, just ask. You ask me, my family name is this one, which data set should I do? Statistical project 2, the same procedure. Submission, 11 October. 2 weeks before that, I will submit. You have 2 weeks to finalize. The reason why we put this 11th of October, because we need a little bit time also to mark it and to give also feedback. Hello? Do you belong to the group? So there are space here. Huh? So we need a little bit of time to mark the assignment and to give you also feedback before you go to the final exam, because it is really important. You would like to know what your mark is before you go to the final exam. If you get a good mark, then you will be relaxed a little bit, isn't it? If the mark is not that good, then, but usually the projects, many students get a good mark in the project. 30% project, if you get 20 out of 30 in your project, because the project is 30%, if you get 20% out of 30% in a project, don't be that much happy, because that's not a very good mark. You should aim 27, 28, 29. And it is achievable. You could achieve that. Final exam, lecture 5, 6, 7, so not included here. So we cover 1 to 4. The rest would be final exam. The final exam, lecture 5, 6, 7, 8, 9, 10, 11. And the format is the same, but the duration is a little bit more. So timing is an issue. When you sit in your exam, mid-semester exam and final exam, timing is a little bit an issue because you need a little bit to calculate. So practice is good. If you practice before you come to the exam, that would help you to reduce. So you could check yourself. If I have this particular question, how much time do I need to calculate that? Then accordingly, you could. And again, it would be good to start always with the question that you know. If you are sure enough that you know the answer, you start with that question. And then once you did everything that you know, then you go back to those which you feel that it is a little bit difficult. But that is not a problem until we start the mid-semester exam. Okay, course grading. Probably you know this, course grading. I mean, there is no need to give you this information because everyone knows what the grading is. The reason why I'm posting here is that the School of Economics, our school, the policy, if you get 84.99, then we will not round it to 7. You will get 6. So what does it mean? Definitely, when you get 84.99, after the tutors mark your exam, I will check because you are just borderline. I have to check it, whether there is any way that you would be pushed a little bit. Huh? But what does it mean? If 84.99 is only 6, then please do all the quizzes. Don't simply ignore a quiz because it is only 2.5%. Please come to the exam viewing session. Who knows? During exam viewing session, a tutor, when marking, could make a mistake. You could find a question that gives you 1 mark, 0.5 mark. All these things would be added and would help you. So please don't ignore the viewing session. Please come to the viewing session. You have to get whatever you deserve to get. So this is what I am saying. But overall, I don't want to scare you a lot because for the course, given that we give a lot of material to students, the failure rate is not huge. The failure rate is only 1 decimal. It is 1 digit. A 1 digit, which means it is always less than 10%, the failure rate. So in 2018, which I was teaching the course in last year, second semester, so this is the failure rate. And 22% of the students, or 23%, they got 7. And This is how it was distributed. Even those students who fail, because I usually check who are the students who fail. When I check this one, most of the time, these are the students who didn't try the quizzes. Maybe they didn't do 3 quizzes, only they did 2 quizzes. They didn't come to the viewing session. So those students who are not that much invested in the course would fail. So if you do hard, if you try, then there is no problem of, and it is 7 is really achievable. And then I did also in semester 1, 2019, last semester also I did the course. So this is 2.23. So 17, 15, a little bit less here, but still the failure rate is very low. Okay, usually when I teach the course, I will give you in between 10 minutes or 7 minutes break time. Today we will not have a break. We will just finish without having a break because we already spent a lot of time explaining about the course. So I will not give you any break, but next week you will have in between a break. So this is the textbook. It doesn't matter if you have the previous edition, edition 4, edition 3, it is still fine. Because it's not huge things changed. So if you don't have this 5th edition, but you have 4th edition in the library, or you have from your friends, that's still fine. Okay, so there is a question which I post a survey. So what I did last semester, I asked students a survey. So please, from today until next week, Wednesday, go and do this survey. In this survey, I ask very simple questions. What is your age? What is your shoe size? What is your height? What is your weight? What do you expect from the course? Definitely all of you will say 7. So there are 14 questions in the survey. So please go do the survey. Once I collect the survey, we will use those questions, those information for your project questions. In your project questions, I would ask you, do the hypothesis test between weight and height. So we will come to that. But that is really important. I want to use your own data for your own learning. So I have a survey. So please complete this survey until next week, Wednesday. So it is placed here in the survey part. So if you go click the survey, it takes you only 5 minutes because the questions are very simple. Your height, your weight, your shoe size, your age, your gender. That's all, I think. And how far do you live from UQ to your place? 2 kilometers, 1 kilometer? How long does it take you to come to UQ? 5 minutes, 10 minutes, 20 minutes? So it is very simple questions. Please do that because we use the data for our teaching purpose. Okay, I wish you a good start. So I finish with the information. A good start to win, probably like this. So don't stress too much. There is huge material, as I told you. The content is huge, but don't worry about that. We will help each other and do the course as enjoyable as possible. So how many of you know each other? Do you know each other or you don't know each other? Sitting behind, in front. So let us spend maybe around 2 to 3 minutes. I wrote 5 minutes, but maybe 3 minutes would be enough. Let us spend 5 minutes. You just introduce yourself to a person who is sitting behind you. 3 minutes. Okay. Okay, let us start. Let us start. You will continue in tutorial, huh? Let us start with the course now. So we will talk about the probability and a little bit about discrete probability. Discrete means one, if you count 0, 1, 2, 3, 4, it is discrete. For instance, how many friends do you have? 0, 1, 2, 3. You don't have 1.5 or 1.7. How many TV do you have in your house? It is discrete, 0, 1, 2, 3. You don't have 1.5, 1.3. So we will talk about that. So you collect information, you collect data. The survey that I am doing is simply I collect data. For instance, I ask you to give me a data. That is simply collecting data. But if I want to use that data in order to make conclusion, then I have to know probability concept. The probability concept is connecting between collecting data and using data to make a conclusion about the population. You take a sample. If I want to talk about the whole of you, I take a sample of students. Based on the sample, which I collect data, I make the conclusion about the whole, then I need this probability. So this is the probability that you get hit, the probability of the car, the probability of throwing a die. This is all to do about probability. So what is probability? It's simply the likelihood. What is the probability that you would get 7? 50%, 70%, 80%. So the likelihood that something would happen, that is the probability. So probability is the likelihood. What is experiment? Experiment is the process of measuring. For instance, if you flip a coin, it is one experiment. You throw a die, this is also one experiment. It is a process. You are flipping a coin to see whether it is head or tail. You throw a die to see whether it is landing on 1, 2, or 3. So that is also an experiment. So probability is the likelihood. Sample space is all possible outcomes. For instance, if you flip a coin, the sample space is head and tail, the possibility. If you throw a die, the sample space is 1, 2, 3, 4, 5, 6. So 6 are the possibility. You don't have more than 6. So the sample space is all the possible outcomes. Flipping a coin, possible outcome, head or tail. Throwing a die, possible outcome, 1, 2, 3, 4, 5, 6. Event means one or more outcome. If you flip a coin, it could be head or it could be tail. So that head is an event. One or more outcomes of an experiment. Let's say the experiment is throwing a die. Then the event would be getting number 1 or getting number 2. It is an event. Getting a tail when tossing a coin or rolling an even number. For instance, you throw a die. What is the probability that it would be even number? Which means landing on 2, landing on 4, landing on 6. So everything, one or more outcomes. Why I say one? If you flip a coin, it is only one outcome, head or tail. But when you throw a die, you could ask a question, what is the probability when you throw a die that it would land on even number? Which means it could be 2, it could be 4, it could be 6. So more outcomes. The probability would be probability is between 0 and 1. The 0 is impossible. The 1 is certain. We don't talk about something which is certain. So if it is certain, there is no need to talk. If it is impossible, there is no need to talk. We have to talk only between 0 and 1, which is the probability. An impossible event has no chance. So if it is impossible, the probability is 0. Example, the probability that tomorrow is Friday, if today is Monday, is 0. So that is totally impossible to happen. A certain event also was something that is sure. If today is Thursday, the probability that tomorrow is Friday is certain. We don't need to guess because it is understood. We don't need to talk about likelihood, the probability. So 0 and 1, probability is somewhere between 0 and 1, between certain, between impossible. What about simple and joint events? So we will talk about this one also when we do more things. The event of getting 1 on the die is a simple event. You see, you throw the die, the probability of landing on 1, it is a simple event because it is only 1, or it could be 2, it could be 3, a simple event. But sometimes it could be a joint. For instance, I could ask, what is the probability of being female? Being female, it is a simple event. If I say, what is the probability that it is a female and from Asia? Then it is a joint. I am joining two things. So, what is the probability that a person is a male? It is a simple event. What is the probability that the person is male and from Europe? Because you have joint or compound. Suppose, but again, a simple event, if you suppose 2 coins are tossed, you have 2 coins, you toss it simultaneously at the same time. So it could be head-head, it could be head-tail, it could be tail-head, it could be tail-tail. So this is a simple event. Because you are throwing together, then whatever is happening is a simple event. If you throw only 1 coin, the simple event is whether it is head or tail. If you do together, the simple event is, but if you make it a joint, you could make it like this. At least 1 head. You throw a coin, 2 coins together. What is the probability? At least 1 is head. So it could be this one, it could be this one, or it could be this one. So we have 3 different possibilities. So that is a joint, because the outcome is 3. The same thing like female and from Asia. And here you flip 2 coins simultaneously at the same time. And then what is the probability that at least 1 is head? This is the whole outcome. The whole outcome is head-head, tail-tail, head-tail, tail-head. So that could be also a joint. So don't be confused when you see 2 things that you might think, oh, this is joint because it is H and A. No, it's not a joint. It is simple because you are flipping 2 coins together. Complementary is the opposite. If you flip a coin and you find head, the complement would be tail. If you throw a die, and you get 1, what is the complement? What is the complement? If you throw a die, you get 1. What is the complement of that? 2, 3, 4, 5. So things that doesn't happen. You flip a coin, if it is on head, the complement is tail. You throw a die, if it is number 3, the complement is 1, 2, 5, 6. Mutually exclusive means they are disjoint. There is no connection. If you flip a coin, it could either be head or tail, but not at the same time head and tail, unless and otherwise the coin is a little bit damaged. It could be either head or tail, but not head and tail together. So they are disjoint. There is no connection between the 2. Mutually exclusive means disjoint. Example, when tossing a coin, either a head or a tail might turn up, but not both. So in that case, they are disjoint. The same thing, if you throw a die, 1 and 2 are disjoint, or 1 and 3, or 1 and 4, because you will not see a die when you throw 1 and 2 together. It could be landing either on 1, or on 2, or on 3, so they are disjoint. What about independent? How do we call that independent events? 2 events are independent. There are 3 possibilities that we would call 2 events are independent. 1, the 2 events are unrelated. For instance, you flip a coin, you throw a die. Whatever happening here doesn't affect the other one. I am flipping a coin, I am throwing a die. Whatever the outcome of this one does not affect the other outcome. It is independent. The second one, you repeat. For instance, you throw a die. You throw a die, you get 5. But again, you repeat it. When you repeat, you are starting from new. It could be again 5. My first throw doesn't affect my second throw. The outcome of the first throw doesn't affect the outcome of the second throw. You are just simply repeating. You flip a coin. It is head. then you do it again. It could be head again. It could be again head, because the first activity does not affect the second activity. So they are independent because you are doing it again. The third one, you repeat the same activity, but you replace. So what does it mean? You have 3 balls. You have 3 balls. You take 1. What is the probability of taking 1? You have 3 balls. You take 1 ball. What is the probability of that? 1 divided? 1 divided? 3. By 3. Then you replace the ball back. What is the probability of picking 1? Again, 1 over 3. My first activity doesn't affect the second one. What about now? You have 3 balls. You take 1. What is the probability of picking 1? 1 over 3. But I put the ball aside. Then again, I pick another ball. What is the probability? So my first one affects the second probability because 1 ball is removed. Because of that, the probability would be changed. So the second activity is somehow determined by the first one. So these are the 3 possibilities where 2 events could be independent. 1, the things that you do is separate. Flipping a coin, throwing a die. Second one, you repeat it. You flip a coin, you get head. Again, you flip another one. When you flip the second time, you are starting from new. The first one does not affect the second one. And this one is you repeat and replace. You replace back the ball. If it is dependent, you see, let's say you have 3 white balls and 4 black balls. 3 white balls, white. Then this is dependent. So what is the probability of drawing 2 white? You pick the first white, it will be 3 out of 7. But you put it aside. Then the remaining balls is only 6. And you have only 2 white balls now because 1 white ball is gone. This probability depends on this outcome. 6 would reduce to 7, would reduce to 6. From 3, we go to 2. Because we have 3 white balls, now 1 ball is gone. We will have only 2. So this is a type of dependent. Collectively exhaustive event means that all events, any of the sample space is possible. To give you an example, head and tail are collectively exhaustive. What does it mean? If you flip a coin, what are the possible outcomes? Head and tail. If you throw a ball, what are the possible outcomes? If you throw a die, what are the possible outcomes? 1, 2, 3, 4, 5, 6. So that is collectively exhaustive. It could be 1, it could be 2, it could be 3, it could be 4, it could be 5, it could be 6. When we roll the die, one of these outcomes must occur. So the definition which I gave here, all possible events are likely. It is possible that it could be 1, it could be 2, it could be 3, it could be 4, it could be 5, or it could be 6. So collectively exhaustive means you have all of them, and one of them could be possibly the answer. So events are collectively exhaustive if their union is the entire sample space. The union, if you put all together, they are equal to the sample space. The sample space in the first slide that I explained. We will have a couple of examples about that, which would tell us whether it is mutually. So mutually exclusive, think in your mind, disjoint. Collectively exhaustive means all possible outcomes are likely. Let's go to one example. The set of all possible die rolls. What are the set of all possible die rolls? 1, 2, 3, 4, 5, 6. Is both collectively exhaustive and mutually exclusive. Why it is collectively exhaustive? Because the union is the sample space. Why they are mutually exclusive? Who tells me why it is mutually exclusive? Because if it lands on 1, it will not land on 2 or 3, 4, 5, 6, yeah? They are disjoint. The outcome 1 and 6, the same example, the outcome 1 and 6 are mutually exclusive. Why? Because you would get either 1 or 6, but not both of them together. They are disjoint. But they are not collectively exhaustive. Why? Why they are not collectively exhaustive? Because what is missing? 2, 3, 4, and 5 are missing. So if something is missing, is not collectively exhaustive. Collectively exhaustive is this one. Here it is missing. But they are mutually exclusive. They are disjoint. If you throw a die, 1 and 6, you will not find 1 and 6 together. The outcome even, the same example, even means 2, 4, and 6. And not 6, which means 1, 2, 3, 4, 5, are collectively exhaustive. Why they are collectively exhaustive? Why they are collectively exhaustive, this and this? Because we have all the numbers, 1, 2, 3, 4, 5, 6. Why they are not mutually exclusive? Why they are not mutual? What is mutually exclusive? Disjoint. Why they are disjoint? Why they are not disjoint? Because because 2 is here, 4 is here, and 6 here. So 2 and 4 are here. So they are joint, they are not disjoint. So their union is not the entire sample space. The union means 1 and 6 is not equal 1, 2, 3, 4, 5, 6. So their union, 1 and 6, is not the entire sample space, is not 1, 2, 3, 4, 5, 6. 1 and 6 is not 1, 2, 3, 4, 5, 6. Now let's go to the 3 approaches. One is a priori, the second one empirical, the third one subjective. The a priori, you have already knowledge. For instance, if we flip a coin, everybody knows it could be either head or tail. So we have already knowledge about that. We don't need information, we know that. I put an example of a card. Maybe in some countries you are right, maybe you don't have these 52 cards. But let us assume we all know about these 52 cards. So that is a priori. There is something that we already know. And then a question could be asked. Empirical is information must be given. I would say to you, for instance, there are 500 people, students. Out of 500, 30 are from Africa, 50 are above this age. This is information, which is empirical information that I give you. You don't have that in your mind. I give you, based on that information, you calculate the probability. The third one is subjective. So let us stick with the first one, a priori. A priori classical, you have prior knowledge. Die is a good example. In a die, we have already a prior knowledge. It could be between 1 and 6. We have prior knowledge. We know already about that. We don't need to get information. We don't need anything. We have already that. Another example that it could be here, a coin. When you throw a coin, you have already the knowledge that it could be either head and tail. Again, an example that I say, a 52 playing cards, a deck of 52 cards. Let us assume, some of you might say that I don't know, in my country we don't use those cards, but let us assume that we have all a prior knowledge. So this is an example which we have a prior knowledge. I have a prior knowledge about this one. This is a prior knowledge. I know already if I flip a coin that I would get. Now the question would be here, requires that you know the number of outcomes. If I ask, what is the probability that it would be a face? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. X will be 12. What is the total? The total is 52. So 12 divided by 52. So X, let us take, because this X is something to do with the next slide. So in the prior probability, you know the number of outcomes. For instance, what is the probability that it will be 3? I know already there are 4 3. I know already there are 4 3. If the question is what is the probability that will be us, which be or A, then we know that it is already 4. So I have requires that you know the number. You already know the number. If I ask you about the coin, you already know that there is one tail and one head. And you know the total. So let's take an example. The probability of selecting a face out of 52 is 12 divided by 52. Whole is 52, face is 12, 12 divided. So x, this is the x that I put, and the t is, let's say, the total. So you have a prior knowledge. Let's go to the second example, which is this one. You require that you count the frequency. So you have to count the frequency. This is empirical probability. You don't have a priori knowledge. You don't have a priori knowledge, but you count and you arrange it accordingly. Let's take an example. This is an example which you don't have a priori, but somebody must tell you. Let's say that male 40 taking statistics, female taking statistics 32, male not taking, female not taking, the total is 173. If I ask the question, what is the probability of a male taking statistics? A male and taking statistics, male taking statistics 40, what is the total? 173, this is the probability. Selecting a male taking statistics. So this is empirical information. Information is given. Based on that information, you calculate. You know to count the frequency. How many male taking statistics? How many the frequency? 40. You count the frequency, 32. Based on those information, you calculate probability. The first one is you have a priori knowledge. You know already about this card. You know already about this. But the second one you don't know. It will be given. Subjective. What about subjective probability? Subjective, as its name indicates, you see, so far we use formula. We use formula. In the case of subjective, we cannot use a formula because, as its name indicates, it is subjective. For instance, if I ask you a question, let's say, who would win the game if there is a World Cup? If there is a World Cup, what is the probability that Italy would win? You might say 30%. Another person would say 70% because he spent his holiday in Italy. He might favor Italy. Another person might say 10%. It is subjective. It depends how you would think about that. So in a subjective probability, there is no formula because everybody would say differently. What is the probability that there is an example which I put. What is the probability that in this case, Brisbane Bronco, Melbourne Storm? If you are from Brisbane, probably you would say 90%. If you are from Melbourne, you would say maybe 90%. So the question could be answered differently. It is subjective. There is a lot of bias. If you live in Brisbane, you would put a very huge probability because you favor that game or that team. So subjective, there is no formula. There is a lot of personal bias. What you answer, what she answers could be different, the probability. So there is a lot of personal bias. I would say Brisbane would win 70% because I like simply Brisbane. So I am biased a little bit because I am from Brisbane. So there is no calculation for that. Now let's go to the same example, empirical probability. As you could see, the probability, this is promoted. Men promoted, let's say these are people working. So the number of men who promoted, the number of women who are promoted, the number of men not promoted, the number of women not promoted out of the total. Now let us divide it all by 1,200. This is the total. Let us divide it each. 288 divided by this, 672 divided. So let us divide it the whole. So this is what we would get. Now you see, the simple probability and the joint probability, I will explain again. The probability of promoted is 0.27. It is a simple probability because the probability of promoted. If I say the probability of a male and promoted is 0.24%. So it is joint. The probability of men and not promoted, 0.56%. Joint probability. The probability of men, 80%. The probability of women, 80%. only simple probability because you are talking only about a single thing. In a joint, you are combining. So anything on the red are simple probability. Probability of promoted, 27%. Probability of not promoted, 73%. Probability of men, 80%. Probability of women, 20%. In the middle here, these are joint. Promoted men, promoted women, not promoted men, not promoted women. So this is, the blue, light blue, is a joint probability. The red ones are the simple probability. Sometimes also there is another name for that. We will come to that. So this is all what we did already. The probability A, the probability A2. So we did all these things. The probability and there is always a woman and promoted. Is there any difference between this and this? If I say the probability of promoted and men is 24. Can I say also the probability of men and promoted? Can I say the probability of A and B? Again, B and A. Would it be the same? This is the same. It is all the same. Huh? So this is the same probability. You don't need to. This is the decision tree. Now, let's go to the rules. There is an addition rule and multiplication rule. There are two rules. In the addition rule, this is the first thing that addition rule, when it comes to your mind, when do we use addition rule? We use addition rule if the question is asked or, A or B. If the word or is coming, it is addition rule. Then the second question that you have to ask yourself, is it joint or disjoint? Is it mutually exclusive or not? So, because you see or, it is addition rule. The second question, if it is mutually exclusive disjoint, then the probability A or B is probability of A plus B, probability of B. If they are joint, then you deduct that joint. This is the joint one, so you deduct it. Otherwise, it would be a double counting. So, when the question is or, addition rule, the second question that you have to ask, is it mutually exclusive or not? If it is mutually exclusive, probability of A plus probability of B. If there is some joint, probability of A plus probability of B minus probability of A and B. This is disjoint. They are separate, disjoint, this example. So, probability of A plus probability of B. Let's take one example. In a group of 101 students, 30 are freshmen and 41 are sophomore. You cannot be first year and second year at the same time. Let us assume. You would be sophomore student, or you would be first year student, or you could be another. So they are disjoint. You couldn't be both. So in that case, because it is disjoint, because it is mutually exclusive, probability of A plus probability of B. So 30 divided by 101, probability of freshman. 41 divided by 101, probability of sophomore. You add them, that's fine. Because they are disjoint. When we come here, it is joint. So we do probability of A plus probability of B, but we deduct this one because we are counting twice. So we have to remove that. Let's take an example. In a group of 100 students, 101 students, 40 are juniors, 50 are female. Here you see, you could be junior and female. So there is some joint. You could be from China and a female. You could be a male and from, so it's possible, it is joint. So junior, 50, 22 female juniors. So there is some form of joint. Now the question is, a junior or female? How do we calculate? The probability of junior plus probability of female minus probability of junior and female. So in your exam, probably I would ask you this type of question, so you have to create the table yourself, yeah? So based on this one, I created the table. So the probability of junior, it is a simple probability, 40 divided by 101. The probability of female, 50 divided by 101. The probability of junior and female, 22 out of 101. So we finish with addition rule. In a multiplication rule now, you ask another question. In order to apply multiplication rule, if the question is and, not or, but and. If it is and, then multiplication rule. Then you ask a question, is it independent or dependent? In the case of addition, or. The question that you ask, mutually exclusive or not? When you come to the multiplication, and, the question that you have to ask, is it independent or dependent? So the probability of A and B, if they are independent, probability of A times probability of B. If they are dependent, otherwise means if they are dependent, probability of A times probability of B given that A. So this is given that. The probability of A times probability of B, but the previous outcome was already A. Given that, it is A. So we will come to that. Now, how do we test? If I give you information, how do we know that two events are independent or not? If the probability of A given B equal to probability of A, or if probability of B given A is probability of B, then you would conclude that A and B are independent. If it is equal, then it is independent. But sometimes you would understand that there is some kind of dependency. Let's go to example. This is independent. Roll a 1 on the first roll, rolling a 1 on the second roll. You roll a die, you do again. My second activity would not be determined by the first one, isn't it? I throw the die, it could happen whatever. Again I throw. My second throw, the outcome of the second throw will not be affected by the first one. Whatever it happens in the first one will not be affecting my second throw. So it is independent. There is no dependency. The same thing, you flip a coin, again you repeat a coin. The outcome will not be influenced. So probability of A times probability of B. Probability of A, 1 over 6. Probability of B, 1 over 6. Because the die has 6 faces, 6 numbers, then the answer is 1 divided by 36. Let's go to the other one. You see, set aside. You have 3 red balls, 3 black balls. If you set aside, if you take out the ball and put somewhere, the second outcome would be influenced by the first outcome. B given A means the probability of B is affected by but what happened in A. So consider there are 3 red, 3 black. Consider the event. The first ball is red. Okay, the first ball is red. Simply, what is the probability that it would be red? 3 divided by 6. But now you set aside. How many balls remaining? 5. How many red? 2. You see? Now, if you ask a question about red, the outcome of red would be influenced because you have already 1 red. So, the second ball is red. So, the first ball is red, 3 divided by 6. The remaining is 5. Again, the second ball is red, 2 divided by 5. So, the probability of A, you see, this one is the probability of A. The second one, the probability of B, given that A is already happening. So, given that, in the first, you have already picked red. The color of the first ball has an effect on the probability of the second ball. Because we already took a red ball, it would influence the second question. It would influence this one. Okay, now let's go to the conditional probability because we say that this given that. Sometimes it is a little bit confusing during exam, during your exercise tutorials, because the word would be confusing. So you might find a number of words, given that, if, of, when, suppose. So these are most of the time the words that are used for a conditional probability. Conditional means always, what is the probability of A given that B already happened? B is already happening. So what is the probability of A given that already you know that B happened? Given that another event has occurred. So how do we solve? Probability of B given A, we can calculate. Probability of A given B, probability of A and B, then divided by this one, the probability of B. If it is written this way, probability of A, can we write probability of B and A? Can we write B and A? Can I write here B and A instead of A and B? Yes or no? Yes. So probability of A and B or B and A, but you have to divide by this one, always by the A. So this probability of A is always a simple probability, the probability of man, the probability of woman, the probability of promoted, the probability of not promoted, but this one is joint, A and B, man and promoted, man and not promoted. Now let's go to this example. A jar contains black and white marbles. 2 marbles are chosen without replacement. The probability of selecting a black marble and then a white marble, a black marble and white marble, you could write whatever, is 0.34. So black and white, or white and black, you could write in here. And the probability of selecting a black marble on the first row is 0. The probability of black is 0.47. Now the question, what is the probability of selecting, always read the question, what is the probability of selecting white? So the question, what is the probability of white? Given that black is already happened. Given that black is already happened. So the question is this one, what is the probability of white? But it gives you information, but keep in mind that black is already happened. So probability of white given black, you could write probability of black and white, or white and black, it doesn't matter, divided by probability of black. Now there is the third concept, which we call a Bayesian theorem. The Bayesian theorem saying that if you have a prior probability and if you have conditional probability, you could revise your probability. So the Bayesian theorem is saying that if you have a prior probability means the probability of white, the probability of black. This is a prior probability. Let's say a prior probability means the probability of white, the probability of black, the probability of A, the probability of B, the probability of C. Let's say this is prior probability. In addition to that, if you have information about conditional probability, like probability A given B, probability B given B, B given A, if you have that information, you could revise the a prior probability using a Bayesian theorem. Please concentrate, because usually I say that from the probability, the addition rule we did, the multiplication rule we did, the conditional probability we did, the one that's a little bit confusing, not much, but a little bit, is the Bayesian. So concentrate on that, because I usually ask that question in the exam. Okay. So once you have the conditional probability, we can use that information to revise. This concept can be extended to revise probability based on new information. What is new information? New information is the conditional probability. You have a prior probability, but if you have conditional probability information, then you could revise the probability. This is what we call the Bayesian theorem. Now, please ignore this one. Please ignore the red one. just read this, the first part. Assume a particular type of printer cartridge available in a market is produced. So firm A produces 65%, firm B or company B produces 35%. If you select one cartridge, and you find this cartridge is defective, don't read this red one, don't read the red one, only read the black. So after you read this one, I'm asking you one question. If you, let's say that you pick a cartridge and then you found it is defective, what is the probability that it comes from company A? What is the probability? Company A produces 65%, company B 35%. What is the probability that defective comes from company A? 65%. You would say 65%. What is the probability it comes from company B? Now Bayesian is saying that, no, we have to revise. We could revise this one based on this information. If we have the information written on red, we shouldn't say that it comes 65% from company B. We shouldn't say 35% of defective comes from company B, because the conditional probability, the new information, could help us to revise our probability. We could revise this probability. How do we do that? Let's go to that example. Keep in mind, 4% of the cartridges produced by company A. What does it mean? 4% of the cartridges produced by company A. Given that it is produced by company A, the probability that it would be defective is 4%. The probability it would be defective given that it is produced by company A. This is how you change the words into mathematical. 4% of the cartridges produced by company A are defective. So the probability of defective, given that it is produced by company A, is 4%. We have a conditional probability. We have a prior probability. If we have this information, we could revise this one. We shouldn't say 65%. We shouldn't say 35%. Now, let me ask you one question. When you do the revised probability, based on this information, which is written in red, and when I calculate the revised probability, my revised probability would be less than this one or more than this one? Less. Why? Why you say less? Because it is revised? Just because here it is 4, but here it is 6. This is small. Now A is small. Now for B it is big. So this information, this 4, would make this one to be less. This information is a little bit higher, would make this one higher. So what do you think the revised for this one? Would it be higher than 35 or lower? What do you think the revised for this one? Higher than 35 or lower? Higher. Why? Because you have 6% here, bigger than 4%. So let us do that one. I have written a number of slides, but don't worry about, there are 2 ways that you could calculate this. The important thing in this question is to understand, to change the question into mathematical things. Once you do that, the way you calculate is not difficult. Keep in mind, a cartridge could be defective, A and defective. It could be also B and defective, isn't it? A defective could be, for instance, like what we did. You could be a man and promoted. You could be man and not promoted. So a combination of 2 is, it could be also defective. But that defective is equal defective A, defective B. Defective A plus defective B would be equal defective. Okay, let's go to that information. So this is the whole things that I already said. This is prior probability. The probability that A produces cartridge 65%, probability B produces 35%. Let us assume this cartridge is only produced by these 2 companies. The probability that it will be defective given that it is from company A is 4%. The probability that it is defective given that it is from company B is 6%. So the important thing is to convert this one. 6% of the company B cartridge, given that it is from company B, the probability that it will be defective is 6%. Now, the question is this one. How do we calculate this one? Two ways that you could calculate. Two ways. One, first work out this one. How do we work out this one? If you want to work out probability of defective given A is equal to probability of defective and A divided by probability of A. Probability of defective given B means probability of defective and B divided by probability of. Once you have that, you could answer this question. So there are two ways that you could answer. I put it somewhere here, I think. I am trying to answer the first one. Probability A given, because the question that is asking, a customer purchases a new cartridge. The cartridge is tested and found to be defective. What is the probability that company A produces that cartridge? Given that it is defective, what is the probability that it is from A? Because the first thing, it is pick it, it is defective. Given that it is defective, what is the probability that it is from A? That is the question. So how do we calculate the first one? There are two ways. One, you could just simply calculate this way. Probability of A given defective, probability of A and defective divided by probability of defective. Simple like what we did in the conditional. The second one you could use this way. The probability of A defective, you make it the opposite. Defective and A times probability of A. The whole these things bring it back here in the denominator, and then you add the remaining. Keep in mind, defective could be A, defective could be B. So this is for A, and this is defective for B. So these are the two ways. In some questions, I can have A, B, and C. So in this case, defective, not defective. But it could be promoted, remain the same, demoted. So it could be 3. So if you have more numbers, it could continue. So if you see the textbook, in the textbook, you could see ... Why? Because in this case, we have defective and not defective. Or we have only 2 companies, but you could have 3 companies. Company A produces 20%, company B produces 30%, company C, company D, you could have more. If you have 4 companies, you could have 1, 2, 3, and 4. So the formula, the general formula, you would find ... So these are the ways that you could calculate easily. As I told you, you could calculate first this one, or you could jump to this. So let's do this one. Let's do this one. I am solving defective given A minus A and defective divided by probability of A. So I know defective and A 4%. I am calculating this one. I know probability company A 65. So it could be A and defective 2.6%, B and defective, because defective could be from A, defective could be from B. The same thing, sorry to take you back, the same thing like what we are saying here. It could be not junior male, not junior female. So this not junior is a combination of not junior male, not junior female, the same thing. Defective also, it could be defective and A, it could be defective and B. So defective means defective and A, defective and B. So the addition of this one is defective. So if you add this one, it will be defective, because defective can be from A, defective can be from B. Now the revised probability based on the information that I gave you could calculate easily. What is the probability A given defective? A and defective divided by probability of defective. Keep in mind, probability of defective is the addition of these two. Defective can be from A, defective can be from B. So if you add, it is the probability of defective. The same thing, the probability of promoted. The probability of promoted could be promoted and men, promoted and women, the same thing. So you see, the revised probability from 65% reduced to 553. The revised probability from 35% increases to 447. Why? Because of this new information. What is the new information? The new information is the conditional probability. This information helps me to revise this probability. I revised the probability, and the probability is now 55% and 40-something%. So Bayesian theorem is saying that because without reading this red, you would have said that if you find defective, what is the probability it comes from company A? You would have said 65%. If you find defective, what is the probability that it comes from company B? You would have said 35. But if you have this new information, which is conditional probability, then you could revise. You shouldn't say 65, you should say different. And in our case, the different is less for this one, more for this one. So please, you have tutorial questions. I will give you also additional questions, but make an exercise of this one because it would have, it probably would be asked in the exam. Huh? It is too early. I don't want to scare you, but okay. So again, this one, defective could be A and defective, B and defective. The same thing, the probability of promoted can be man and promoted, woman and promoted. If we have 3 companies, what would you do? If you have 3 companies, the probability of defective would be A and defective, B and defective, C and defective. So here you would have plus, again, defective given C times probability of C. So it could be more than 2 sometimes. So 55% is lower than 65% because of this 4%. This new information or conditional probability helps me to reduce from 65 to 55.3. And it helps me to increase from 35 to 44.3 because of this one. So this is just simply additional information. So the main thing that you have to concentrate is you could calculate in 2 ways. We have done already the first way. You could do also the second. So these are the 2 ways that you could calculate. Either using this one or you could use this one. And systematically in these 4 slides, we have done already. So probability A defective, A and defective divided by defective. Probability B given defective, B and defective divided by, or you could apply the Bayesian. This is the number of companies, company B1, company B2, something. So you have many companies. You could also use the formula using A given defective, defective given A times probability of A. You put the same thing here again, plus you add the other one, the other company. So you could use, so you have prior probability is 65% and 35%. New information is conditional probability, which is the 4% and the 6%. And you apply the formula, you revise your probability. Instead of 65, you reduce to 55%. Instead of 35, you increase to 40, I don't know, 43? Okay, so please, you could use either formula. The formula sheet would be given, so you could apply one of the 2. Now let's go to the counting rule. The counting rule, for instance, if you flip a coin 2 times, twice, you have a coin which you flip, and how many times you flip. A coin, what is the outcome of the coin? Either head or tail. So it is K. It could be head or tail. This is the number of flip. If you flip a coin only one, what are the possible outcomes? If you flip a coin once, what are the possible outcomes? Head or tail, so 2. So the coin has head and tail. The number of flip is n. You flip once. If you flip a coin twice, this is the coin has 2, head and tail. You flip it twice, then it would be 4. So head, head, tail, tail, head and tail, tail and head, isn't it? What about if you flip a coin 100 times? Then you have to apply this formula. This is always what you would get, tail and head. This is the number of flip. Again, this is rule number 2, is n factorial. Do you know what this factorial means? What is 3 factorial? 3 factorial means 3 times 2 times 1. 10 factorial means 10 times 9 times 8 times 7 times 6. What is 0 factorial? 1, okay. Now, let's say there are 3 places. There are 3 places only. In how many ways could I put these 3 people? 3 places, 3 people. I am not saying 3 places, only 2 people. I said there are 3 places. In how many different ways could I put these 3 people in these 3 chairs? That is what rule number 2. You have 3, you are A, you are B, you are C. I can put A, B, C, A, C, B, so these are the different combinations. Now, keep in mind, 3 places, 3 people. I didn't say there are 3 places. How many? 2 people. I didn't say. If I say 2 out of 3 places, it is a subset. But what I am talking here is that there are 3 places. In how many ways could I arrange these 3 people? The next 3 and 4, it is a subset. I am taking a subset. So when I go to, this is already, we did that. So order matters. Actually, what does order matter means? Actually, A, B, C, and A, C, B is the same, but the order is different because this is A. I put him first. Then I can change the place. The people are the same, but the order is important. Here, the order is first coming A. Here also the order is A, but the second one is B here. The second one is C. So the order is important. I don't need to ignore the order. Let's go to 3. Order matters again. This is a subset. You take a subset. What we call this one is permutation. This is how you would calculate n factorial, and x is the question. X is the question. Order matters. If there are 6 textbooks, but room for only 4, you see? 6, I'm talking about 4. 4 is a subset. There are 6 textbooks. You have 6 textbooks, but the shelf is only for the 4. In how many different ways you could do that? So order also matters. If order matters, it is permutation. This question could be confusing, but usually, so in this case, 6 textbooks, n is 6, but the question is about 4. So x is 4. The question is about 4, n is 6, 6 factorial, 6 minus 4 is 2 factorial, so you would get 360. If a question is about permutation, which order really matters, the question usually is like this. If you take this, is it in your lecture note, this one? Is this one in your lecture note? You could write it if you want. So a permutation, a club has 9 members. In how many ways can a president, vice president, secretary be chosen from the members of the club? So what is n? N is 9. What is x? 3. Why do I say order matters? Why do I say, why this question is order matters? Because the first one is president, the second one, vice president. Who can change this question to order doesn't matter? Change this question so that it will be order doesn't matter. Only 3 people. In how many ways can we choose 3 people? Huh? If that is the question, we don't care about the order. So this one, order matters because the first person must be president, the second one must be a vice president, the second one third. So order matters. If I want to change this question, I would simply say that 3 people out of 9, a subset. Order doesn't matter, it is a combination. You see this question, order doesn't matter. But if I change this question to order matters, A, B, B, A. Here I don't care about the order. A, B, A, C, B, C. They are different. But here, the order is important. I put A, B, but A is the first one. Now I make it B, the first one. So the order is important. If you ask the same question to use rule 3 and rule 4. Usually, a combination type of question could be formulated in this way. A club has 9 members. In how many ways can a committee of 3 be chosen from the members of this club? I don't care about the order. It is only 3 people that I am asked. The first person could be male, could be female, could be president, I don't care. In the previous case, the order is important. The first person must be president, the second vice president, the third is secretary. So please try to differentiate. One thing that you differentiate, it is a subset. 9 from 9, 3. It is a subset. The second thing that you have to see, whether order matters or order doesn't matter. Here, order doesn't matter. In the rule number 2, I gave example. There are 3 places in a chair. In how many ways? These 3 people. It is not a subset. 3 places, 3 people. In the previous case, 6 books, 4 shelves. It is a subset. 6 is the whole, 4 is a subset. So it sometimes could be confusing between permutation and combination, but the question can make it a bit clearer. We will do more exercise about this one. Usually, once I finish this lecture, when we come next week, we would do a couple of questions from lecture 1 at the beginning of the class before we start lecture 2. The same thing before we start lecture 3, we will do a couple of questions from lecture 2 so that we will revise again. Now let's go to the probability distribution, which is the last part. We will talk this one next week. Let's talk about discrete. Discrete means, as I told you, simply that you count 0, 1, 2, 3, 4, 5. Number of TV, number of friends, number of house, number of cars. You cannot say 1.5, 1.3. All things that you could count 0, 1, 2, 3, it is a discrete. One form of discrete is binomial. If you see the word this bi, it means 2. Pass and fail is binomial. Yes, no is binomial. Head and tail is binomial. Only 2 outcomes. So let us do the binomial, and we will finish that one. The whole this is about binomial, I think. So this one is okay about the probability distribution. We are talking about discrete probability distribution. When I say discrete, there is no decimal numbers. It could be either 0. If I ask you a question, if I ask you your age, is it a discrete or continuous? If I ask you your age, is it a discrete or it is a continuous? Why? What about you could tell me that I am 20 years old, 5 months plus 200 days plus 5 minutes or something? So that in that case, it is a continuous because it could be continuous. But if I ask you how many TV do you have in your house, you would say 0, 1, 2, 3. You don't say 1.5. So income is continuous. What is your hourly income? $10.25. There are decimals. Huh? So let's talk about discrete. Suppose you flip a coin two times. These are the outcome. So what is n? How many times you flip? 2 times. N is 2. This is the number of times that you flip. N is 2. The possible outcomes are this one. Now the question would come. The question is x. What is the probability that at least there is one head? One head, the probability, at least one head is this one, at least one head is this one, at least one head is one. This is no. So now let the random variable x represent the number of heads that results from this experiment. So if you flip a coin 2 times, the maximum that a head would be is, what is the maximum? X could be between what and what? N is 2. You flip a coin 2 times, N is 2. What about the question X? What is the minimum? Let's say X is head. What is the minimum? What is the maximum? You see, the maximum is equal to the number of flips, yeah? If you flip a coin 5 times, assume X is head. What is X, the minimum? The maximum? 5. Okay, keep that in mind. So, in this case, it is simple to answer the question. The probability 0 head, 1 over 4. 1 divided by 4. The probability 1 head, 2 over 4. The probability of 2 heads, 1 divided by 4, isn't it? So it is very simple. in this case. But what about if I flip a coin 100 times? Then you need a formula. So this is the formula that we would apply. Now, in a binomial, you see, let me ask you one question. You flip a coin. What is the probability of head? What is the probability of head? You flip a coin, the probability that it would be head. Again, you flip a coin, half. But in reality, if you flip a coin 10 times, 7 times could be head. Only 3 times is tail. It could be 2 times head, 8 times. But always let us assume if you do it again and again, at the end it will be 50-50%. That is the assumption. Yes, if you throw a coin 10 times, maybe 7 times could be head. But if we do again and again, at the end it will be 50-50%. So what does it mean? Whether you flip it once, whether you flip it 10 times, whether you flip it 20 times, always we assume this is 0.5, this is the remaining 0.5. In the case of flipping a coin, it would remain unchanged. Whether you flip 2 times, if the question is flipping a coin 3 times, this is always 0.5. This is always 0.5. So P and the Q will never change. P and the Q, they don't change throughout the experiment. Why? Because we assume that the more you flip a coin, at the end you would find around 0.5 for head and for tail. So how do we calculate the probability that it will be 0? 0 head? We don't need to calculate. 0 head is 1 divided by the total 4. This is 1, this is 2, this is 3, this is 4. So the probability of 0 head is 1 divided by 4. The probability of 1 head is 2 divided by 4. The probability of 2 heads, 2 divided by 4. But if the question is you flip a coin 100 times, then we need a formula. That's why we are applying. So if you flip a coin two times, and the question is about head, the minimum head is 0, the maximum head is 2, between 0 and 2. So let us calculate 0. The 0, 25%, 1, 50%, 2, 25%. From this information, we could calculate mean and variance. Now we know this is the probability. You could use the formula, which is easy. If you want for the 0, 1 over 4, 2 factorial, 0 factorial, n minus x factorial. This is always the probability of head, 50%. The probability of tail is 50%. P, probability of head. Q, probability of tail. In some questions, P could be probability of defective. Q, probability of not defective. In some cases, P, probability of failure. Q, probability of not failure or pass. Okay, so this is the probability that we calculate. Now we can calculate mean and standard deviation or variance. How do we calculate mean and variance? Let us go to this is the way you would calculate, but I will show you here how to do that. So we have probability, this is probability, 25, 50%, 25%. If you add, it has to be equal to 1%. So this is how we calculate. This is the mean. 0 times this one, 1 times this one, 2 times this one, and then this is the possible outcomes. 0 head, 1 head, 2 head. This is the probability, this is the mean. This is the mean. Now let us calculate the variance. How do we calculate the variance? We have already this information, 3 columns, 1, 2, 3. Then you have to do only these 3. 0 minus 1, negative 1. 1 minus 1, 0. 2 minus 1, 1. I square it, then I multiply with P of x. 1 times 0.25, 0 times 0.50, 1 times 0.25. I add them, 0.5. If this is variance is 0.50, the standard deviation is the square root of. So we can know the mean because it is important. If the distribution is like this, the middle is the mean, then the other one is the standard deviation. I would leave the other one when you have 2 things, so I would leave that to you. I will not go to cover here. If we have x and y, because it is a little bit time consuming to calculate, so I go to the final part, which is a binomial distribution. how would you think the binomial distribution looks like? Would it look like to the right? Would it look to the left? Or does it look simply like a bell-shaped? How does it look like? It all depends what is your P and what is your Q. In this example, P is the probability of head, Q is the probability of tail. So the experiment involves n identical trial. Number of times, identical. You flip a coin 2 times, n is 2. You could flip a coin 3 times, n is 3. Identical trial. Each trial has only 2 possible outcomes. Binomial. Binomial means 2 outcomes. Head and tail. Yes, no. Defective, not defective. All binomial. The third one, each trial is independent. I flip a coin. My first flip doesn't affect my second flip. It is independent. The outcome of the first one doesn't affect the outcome of the second. So they are independent. The fourth one, P and Q remains the same. Whether I flip the coin 10 times or 20 times, whether n is equal to 10, n is equal to 20, n is equal to 30, P and Q remains the same. This P and Q always remains the same. P and Q, 50% tail, head, 50% tail, would remain the same, whether you flip 10 times, 20 times, 30 times. Why? As I told you, the more we flip the coin, the more times, at the end, we will have 50-50%. But in reality, if you flip a coin 10 times, maybe 7 times you could get head. But the theoretical explanation is that the more you flip the coin, at the end, it would be around 50-50. Now let's do one example about that. So this is the formula. Keep in mind, this is the formula that we are using. This is the number of times. This is the one that the question is. This is the question. This is the information. Information, the question. So let's do one question of that. A manufacturing process created 3.4% defective. If the question is about defective, then P would be 3.4%. And Q would be 1 minus 3.4%. A sample of 10 parts. What is 10? N equal to 10. Now the question is 3 defective. Exactly X equals to 3 is the question. X is equal to 3. So the defective, what is the minimum defective in this question? Could be. Not in this question, but overall in this, 0 is the minimum, the maximum defective? 10. It depends on N. Eh? So there are 2 outcomes, defective, not defective. The question is about defective, so P is 3.4%. And the Q would be 96.6% would be Q. The question is exactly 3. So let us calculate. This is the question. N, 10 factorial, 3 factorial, N minus 3. Then this is the P, because the question is related to defective. This is the Q. So the probability that it will be exactly 3 defective. What about if I ask you the question, what is the probability that it will be less than 3? If I ask you the question, what is the probability that it will be less than 3? Instead of X equal to 3, if I ask X less than 3, you have to calculate the probability for 0 plus for 1 plus for 2. If I less than 3, so 0, 1, 2. What about if I ask you less than 9? 1 minus probability of 10. Yeah, that is the easiest instead of 0, 1, 2, 3. Yeah, yeah. Okay. Again, please make sure what the question is. Here I gave you 45% female. 45% of all registered voters in a national election are female. But my question is male. The information I gave you is female. My question is male. So don't mix P and Q. So here, 55% are male, So the question is about male. Contain 2 male, exactly 2 male. N is 8. The question is 2. 8 minus 2. Then this is the probability that it is male. It is about the question. Don't take 45 as P. P is about the question. Q is the other remaining. So how do we calculate mean? N times P would be in the mean. N times P would be the mean. Then the square root of NPQ is the standard deviation. So in a binomial distribution, how do we calculate the mean? We calculate the mean N times P. P in this case, it could be P about head, it could be P about defective. And what about the standard deviation? The standard deviation is the square root of NPQ. So in a binomial, you have to differentiate. In a binomial, mean is calculated N times P. In a binomial, standard deviation is calculated the square root of NPQ. So this is a simple example again. N is 12. The number of the P is 0.5. So NP would be 6. The square root of NPQ would be 1.73. Now, graphing. You see, the graph of a binomial distribution, it could be a little bit to the right, it could be a little bit to the left, or sometimes it could be symmetrical. Symmetrical means 50% here, 50%. The bell-shaped is symmetrical, 50% here, but sometimes it could be to the right, sometimes it could be to the left. How do we know that? The P and the Q would help us. Now let's take one example. Assume the probability, these are n times, so the number of n, 3 binomial distributions with n equal 8. As I told you, if n is equal to 8, the question could be, the minimum could be 0, the maximum could be 8. Let us assume P is equal to 0.20. Let us assume P 0.50. Let us assume P 0.80. We could calculate for all of them. I started to do the first one when it is 0 and 20%. This is what I got, 0.167. What do you observe in this graph? If it is 50%, you see, the numbers are the same. 0039, 0039, 0312, 0312, 1094, 1094. So this would tell you, if you are thinking only about this, it is a normal distribution. What about this one? Does it go more to the right or to the left? What about this one? Does it go to the right or to the left? You could draw actually a graph, and the graph would look like this. If you use Excel, then the graph, if P is equal to 0.5, then it is symmetrical, a bell-shaped, 50% to the right, 50%. You see, this is the normal distribution. This is the mean, N times P. And this is the standard deviation, the square root of N, P, and Q. What about if P is less than 0.5, which is 0.2, then right skewed. It is confusing. If it is less, it is right skewed. So we might think that if it is less, it is left skewed. But if it is less than 0.5, right skewed, greater than 0.5, left skewed. You could do this one in a graph. Once you have these figures in Excel, you could highlight and you could do the binomial graph. So this is the graph that I have. 0.5, you see, this is symmetrical. Very symmetrical. In the middle, to the right, to the left, half-half. 0.2 to the left. So if you see, it goes from here and going down, 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 down. So what does it mean? Right skewed. Right skewed means if you put the graph would look like this. So it is skewed to the right. If you see here, it's skewed to the left. The graph would look like this. Who can tell me, why do we have a gap here? Why do we have a gap? Why? Because we are talking about discrete. If we are talking about continuous, it would have been together. Because continuous, all decimal is possible. Here, decimal is not possible. Number of TV, 1, 2, 3. The same thing, we don't have decimal. 0, 1, 2, 3, 4, 5. We don't have in between. We don't have in between. In a continuous, we will have that. And then the graph would be together. But having said that, this is the information that I gave you. If P equal to 0.5, symmetrical. P less than 0.5, right skewed. P greater than 0.5, left skewed. This is the general. But there is an assumption also. We don't need to care too much. It will be symmetrical. Always it will be symmetrical if these conditions are fulfilled. If this condition is fulfilled, if n times p greater than 5 and n times q, this is q, 1 minus p, is greater than 5, then it would be approximately symmetrical. Usually this is a condition. If we satisfy, if the question that I gave you satisfies this, then it would be approximately, regardless of the value of p. Don't worry about whether it is 20%, 30%, 40%. Regardless, if this condition is fulfilled, then it will be symmetrical. Again, if your n is greater than 30 and not too highly skewed, the distribution is symmetrical. But mainly this one is the most important. So we finish here. At least you have 8 minutes. That could be the break that I should have given you. So thank you so much for coming today. So see you all next week. The survey, please don't forget the survey. Survey.